This is Mr. Beck Does Your Homework, AP Physics, Homework 3.2, questions number 12 and 13. Question number 12, a block of mass 3.55 kilograms lies on a frictionless horizontal surface. Good. The block is connected by a cord passing over a pulley to another block of mass 2.78 kilograms, which hangs in the air, as shown, assuming the cord to be light, massless, and weightless, and unstretchable, and the pulley to have no friction and no rotational inertia. So in other words, I'm in a wonderful ideal world. Calculate the acceleration of the first block. The acceleration of gravity is 9.8. Free body diagram of this top block. Got gravity down. I've got a tension pulling this way. I have a normal force this way. And that's all I have. I don't have any friction. So this tension will accelerate this block. My other block, my hanging block, has gravity down and has a tension up. Now, when I think about external forces, this tension and this tension is right here and right here. Well, that's between the blocks, so that's an internal force. This normal and this gravity balance each other, so those are going to cancel out. So all I'm left with is this force of gravity here on this 2.78, on this hanging block, which is going to be the mass of that block times the acceleration of gravity. That is my net external force, is my force of gravity on that hanging block. That net force, that external force, is the force that will accelerate both blocks, or accelerate all the mass. So if I'm going to do my net force equals the mass times acceleration, so my acceleration is going to be my net force over the mass. Well, this Fg is my net force, because that's the only external unbalanced force. And the mass is not the mass of one block, it's going to be the mass of both blocks. So I could write m plus m here. It's my total mass. All the blocks are being accelerated by that one net force. So now I know my acceleration of the block. Now when it says calculate the tension in the cord, well, I'm going to look at this top block, because it's might look harder, but it's actually easier, because this tension force is not fighting against anything. So this tension force must accelerate this block. And this block and this block are going to accelerate at the same rate that I figured out here. So if I want the tension in the cord here, then if I look at just this block, and I can do F net equals ma, well, this Ft is my F net. So that's going to be Ft equals m, and this is just the top block, so for me 3.55 times this acceleration that I got there. So this acceleration is a, and that will give me the force of tension in the cord. If you want to do it with the hanging block, then you know that the difference between the tension and gravity is a net force that accelerates that mass. So you could do ma for that and get a net force, but then you're going to have to deal with the tension, that the gravity minus the tension is the net force, so you're going to have to do some math and figure out the tension there. So this is the better way to figure out the tension, is dealing with that top block.